All right, I'll share my screen again and we'll pick up on the second part of history of chemistry. So John Dalton, his four-part atomic theory, this is where we left off. All things are made of atoms. Similar atoms are similar and different atoms are different. Atoms combine to form molecules and chemical reactions do not alter atoms. Well, as we go along now and we get through the 1800s into the late 1800s, I'll give you a few parallels here. Biology, surgery was developing as a true science, and doctors were beginning to look at curing diseases. Um, we had engineers who were using some simple substances to create marvelous structures in the late 1800s and early 1900s. One of the true modern geniuses, Einstein, is born during that time. And we still don't know anything about an atom. All we know is what Dalton has said, that there's these things called atoms, and we don't know anything. Well, J.J. Thomson comes along. He was from England, and he was a physicist. He was working on electricity and magnetism, and what he did was he was working with something that was akin to a television tube. Way, way back when, before flat screen televisions had tubes in them. And they had at one side of the tube a screen that when electrons hit it, the screen lit up and turned white, bright white or gray. And that there were charged plates inside this tube that directed this beam of electricity, and that's how pictures were formed. So in the early days of black and white television, this is how basically it was done. It's called a cathode ray tube. So he was doing experiments with this, and he noted that when he charged up the two plates in the middle, he could direct this beam of electricity one side or the other. And when he knew that when one plate was charged positive and this beam was attracted to it, he was guessing this beam was negative. And from that, he surmised that this beam was actually made up of something termed electrons. So J.J. Thomson did something else, though, that he used this, applied this, and said, you know what? This is part of an atom. And he came up with this idea called the plum pudding model. So in your notes, you should have discovery of the electron is J.J. Thomson, okay? And using a cathode ray tube, okay? The plum pudding model, J.J. Thomson said, here's what I think. It is like a bowl of oatmeal. And except he was from England. And so in England, they really don't eat oatmeal with raisins in it. If he was from America, it would have been probably called the oatmeal raisin model. But in England, they have something called plum pudding, which is kind of a cake that's kind of dome shaped. And it's sort of a yellowish color and has bits of fruit in it, plums in it. It's called plum pudding. And he said, that's what an atom looks like, that there are these things like raisins, the electrons that are just sort of stuck in there among all of the pudding, the cake, the other junk that makes up an atom. And that's what an atom is. And so he said there's electrons, discrete particles, and the remaining is an unorganized, just a gob. Well, this is what plum pudding looks like. If you're ever in Canada, they serve plum pudding. It's often made around the holidays. So the next person who came along, Ernest Rutherford, and he and his students developed an experiment to test J.J. Thomson's model. So now we're early 1900s. Einstein has already written his first paper on theory of relativity. Physics is a vastly developed science. Engineering is moving forward. The Wright brothers have invented the first airplane, and we still don't know anything about an atom. So Rutherford says, okay, I got this, that if an atom is plum pudding and these electrons are in there, then I ought to be able to take something, another atom, and I ought to be able to shoot it through there without it hitting anything, without any deflection. Because if all it is goo and like oatmeal, and he's thinking about firing an atom through it that would be like shooting a bullet through a bowl of oatmeal. Yeah, the bullet would not, nothing would happen to it. It would just go straight through. So he tells his graduate students, here's what I want you to do. I want you to set up an experiment where we have this gun, and the gun is going to shoot helium atoms. And we're going to direct it through a plate so that the beam is focused, and we're going to shoot it at gold foil. And the gold foil has very, very heavy atoms in it, densely packed. And if J.J. Thomson's right, this beam ought to go straight through this plum pudding crap and hit this screen, phosphorescent screen on the other side. All right, so he goes home and tells his graduate students, a couple of guys, yeah, get my experiment going, make it work for me. I'll be back in the morning and we'll talk about the results and what happened. Well, the guys put the experiment together and they go ahead, they turn on the helium gun, and something goes very wrong. They have other screens around the room that aren't really being used. They're not part of the experiment, but they start glowing. And they shut it off really quick because they aren't sure they did something really wrong. And they spent all night messing with this thing, and it wasn't working the way the great Rutherford said it would. So Rutherford comes in the morning, and this is why I think Rutherford is one of the great scientists of all time, because he came in and he said, well, boys, how'd it go? And the guys, well, they were scared because they were worried Rutherford, he's this big professor and famous, and he was going to fire him and kick him out of the university. And they said, well, Dr. Rutherford, here's what happened. We set this thing up and it went through the gold, and all of a sudden all these other screens in the room started lighting up. And we don't know why, sir. We're idiots. We messed up. We're sorry. And he looked at the whole thing and he went, no, don't be sorry. Let's rethink this, because maybe J.J. Thomson is wrong. Maybe an atom is not built like plum pudding. Let's rethink this. So what he did was, he and the boys, they got the screens and they set them up in a circle around the gold foil. And then they got the helium gun, they turned it back on, and they began recording what was happening with all these different screens. And the analogy, the similar thing that they came up with was, wait a minute, these helium atoms are going in there, and instead of going straight through, they're hitting something. Instead of the gun going through and shooting the bullet through the oatmeal, it was more like shooting a bullet through a bucket of rocks. That as the helium atoms came in, that's what this picture is, the helium atoms were hitting the gold atoms, these very dense gold atoms, and were ricocheting. So some ricocheted off in all different directions, and they sat for quite a while and they did all kinds of calculations and figured out that no, J.J. Thomson was wrong, that the atom had something very, very hard and dense at the center of it, which is now known as the nucleus. So we threw out most of J.J. Thomson's model. We kept the electrons. So now, as we get into the 1930s, we know about, it's only about 90 years ago, we know about the atom, we know about electrons, and we know about a nucleus. That's it. All right, then it took one more fella, James Chadwick. And James Chadwick came along, and he's working on the mass of atoms. And what he found was that things were happening with the mass that weren't quite true with what Dalton had said, that he was looking and seeing not all sulfur atoms weighed the same. In fact, no atom of similar types all weighed the same. All carbon atoms don't weigh the same. And he began to think, but they are the same, they're not the same. And what he did was he began to recognize isotopes. That the similarity Dalton had talked about is the number of protons. So we could modify this theory to say that similar atoms are similar. Yeah, similar atoms all have the same number of protons. So all sulfur atoms have 16 protons. All oxygen atoms have 8 protons. That's the similarity. But there was another particle that was letting the weight change. And so from that, he realized that there was actually another particle. And so it's into the 1930s when we figure out that we've actually got uh, 3 main particles uh, in, in the atom. We have protons and neutrons in the nucleus, and we have electrons in some manner and form out and around the nucleus.